So notice I combined these last two statements. A is the midpoint of both wy and zx. So I did make that statement all in one. But I simply copied down my information. I didn't interpret it in any way. Okay, I simply copied it down. Okay, so if I look at this, I'm told that wy and xz are equal to each other. Okay, I'm also told that A is the midpoint of both wy and xz. Okay, so step two, or the first steps in working with a proof are make sure either that you interpret the given information or you introduce the elements from the end state. Okay, so here I have both of those are options, right? I can either interpret this given information that A is the midpoint of, or I could introduce WA and or ZA into my proof. Okay? Either one is fine. And again, I'm just giving you as structured a way to approach proofs as possible. So to me, what I would do is I would look to either introduce the end state here, again, or define or use the given information. End state introductions is always probably going to help you toward your goal of achieving that end state. So let's look to see, can we introduce WA in some way? Okay, so notice I am going to equations here because I'm going to be talking about some equation forms. So what allows me to introduce WA? WA is what? What do you know about WA? There's two things that you can, two relationships that you can identify that involve WA. Dylan, what's one? Okay, so one of them is to say that WA is equal to, and I'm just going to write it AY. You can write YA, that's fine too. But I know that WA and AY are equal, and the reason I know those is what? By definition of midpoint. Okay, so this actually accomplished both of those goals, right? So it allowed me to interpret the given information, definition of midpoint, and it introduced WA. Okay, what about ZA? Can I introduce ZA into my proof? What does ZA equal? Okay, and I'm going to write AX, but you can write XA. Either of those is fine. But so I can introduce this. It's the same justification, right? Because I was told that A is the midpoint of ZX as well. So I know that ZA and AX are equal. Okay, so now I've introduced the elements of my end state. I've also interpreted, so I have everything in here that I can as far as interpreting the information from step one. So now I need to, often in proofs, you need to work backwards or look to see, is there any way that you can start to relate the pieces in order to kind of put them back together and build up to that end state. Okay, so what you're going to see here, and I'm going to try to do this in a different way for each of my classes, and then I'll post all the different proofs that I do so that you can see the different ways that we can approach this. But let's take a look at another way that we can look to introduce. Okay, so we could reach our end state if we can say that AY and AX are equal. Is there anything that allows us to say that in our proof? No, not directly, right? So we have to think of it going a different route. Okay, so let's come back to this idea of this was interpreting our given information. Is there another way that I can introduce WA into this proof that relates the pieces that we are already given? Again, usually in a proof you're not going to get wasted or you're not going to get information that's not relevant. Okay? You're usually going to be given information that plays a role. So is there any way to represent or interpret or introduce WA in terms of this other information that we're provided? Jenna? Okay, so now as far as that goes, that is a true statement. We don't have a specific way to define that. That's not how we necessarily defined the midpoint.
It's a bisected.
It winds up bisecting it, I mean, which is part of the process. So it would take a couple steps to reach that. But let's kind of go, let's build up what you're saying, which is, or actually, let's go through. Let's do it that way. So to say that WA is equal to 1/2 of WY. Okay, so this is, let's see. Yeah, I think we'd have to build into that simply because the way I defined midpoint was cuts it into two equal parts. So let's go back and base this on a different relationship. Matt? Okay, good. So we could say we do have segment addition. Segment addition allows us to introduce parts related to wholes. So if we say that WA is equal to the whole thing, WA is equal to the whole thing, WY minus the other part, AY. And that allows us to introduce and connect the two pieces that we have, WY and WA. And at the same time, we can introduce ZA again in terms of its whole, ZX minus the other part, AX. And so notice, again, I'm defending these statements as being a segment addition, even though there's no addition symbols. Okay? It still represents that concept. Right. So next, where can I go from here? Any ideas? And so again, I need to have, in order to make WA and ZA equal, if there's a way to represent these pieces being the same, you can. And so what do I know that AY is equivalent to? AY is equivalent to WA. So what I could say is that WA is equal to WY minus WA. And I can simply substitute this equivalent value in for AY. At the same time, I can do that down here as well, right? I can say that ZA, take this statement, is equal to ZX minus, and instead of writing AX, what is AX equivalent to? It's equivalent to ZA. So that's also just a direct substitution. Anytime you replace one thing with another, or its equivalent, it is an example of substitution. Okay. And so what relationship can I derive from these statements? What can I do to both sides of this equation now? Or if I add WA to both sides, what do I get on the left side? 2 times WA is equal to WY. And all I did was added the same value to both sides of my equation, so addition property. And do the same thing with the second statement. 2 times ZA is equal to ZX. And so what about my next statement here? What do I know about WY and ZX? They're equivalent to each other, so what can I replace WY with here? WY is equivalent to 2 times WA. And what can I replace ZX with? 2 times ZA. So again, all I did was I substituted that into the relationship that was given. Okay, and so now I can go up to statement 7. What do I do to both sides of this equation? They both have a multiplier of 2, so I can divide both sides by 2, and that leaves WA is equal to ZA. The property used is just division property. I divided the same value from both sides. And now, have I reached my end state? Is this exactly written as I need it to be? My end state is a congruent statement. This is a relationship between measurements. So what's the one thing that I need to do here? Can I convert this back into congruence? If two things have equal measures, what do I know about those things? Their segments are congruent. And I can define or defend that using either definition of congruence, or you can use the common notion things that coincide are equal to one another. A definition of congruence is going to be what you'll most likely see on the multiple choice part of proofs that you'll be exposed to.